Okay, good morning everyone. So let us start with today's class. In the previous class, we have studied about working of single fixed pulley. Okay, now in this class, we will study about the working of single movable pulley. Okay, so which is very interesting. So let us know about what is single movable pulley. So in the previous class, in a short, I have informed you, I have just told you about movable pulley. You can see here once again, we'll go through what is single movable pulley. So you can see in this picture, a movable pulley is a pulley that is free to move up and down with the load. So you can see this picture, and with the help of picture, very easily you can understand what is the concept of movable pulley. So you can see it is moving up and down. Okay. So the next thing, the same thing we have studied in single fixed pulley also, same is for the movable pulley as well. So we know that after seeing this picture, you can see here, this is a movable pulley and this load is nothing but resistive force, because load will be overcoming the resistive force. So resistive force is equals to weight of the box, correct? So weight of the box means the mass of this box due to the acceleration due to gravity. So same thing we have mentioned here. Resistive force is nothing but load, because load is overcoming resistive force. Weight of weight of box means mass into acceleration due to gravity, and mass, we know that is m, is denoted by m, and acceleration due to gravity is denoted by g. So we know that load is nothing but mg. So load is acting in the downward direction due to the acceleration due to gravity. So this we have already studied in single fixed pulley. The same is here for single movable pulley as well. Okay. So now in the next slide, you can see that I have taken here two pictures. Okay, children, on your slide. In the first picture, again we have taken a single movable pulley. But what we can find here, you can find that the tension is on both the segment of the string. So here also same way. But what is the difference here and here? We have to find out now. So you can see here the load is acting downward direction, and for this load, this both the side support is given. That means for the load there is twice tension, correct? Because the tension is supporting this, both the line segment of the strings are supporting this load. So how many times tension is applicable for load? It is 2 times. That is, you can see here T, T plus T. T plus T is 2T. Okay, so 2T is equals to load means nothing but mg. Already we have studied in the previous slide. Correct. In the second picture, in this on the same slide, you can see here, effort is applied upward direction. Okay, and effort is applied only on one string. Correct. Because we are applying only on this string effort. We are not applying on both the string. So effort is equals to what? T. So clear about the load, why load is twice the tension and why here tension is only once for the effort, because for the load the support is twice but effort is applied only once. So E effort is equals to T and load is equals to 2T. Okay. Okay, so here one more example we have taken when the load is at equilibrium. What is the meaning of equilibrium, children? What you can say? What do you mean by equilibrium?
Ma'am, both
What
the
do you mean
sides
by
it will be
equilibrium?
equal, ma'am.
What is equilibrium?
Ma'am, both the sides it will be equal, ma'am.
Yeah, quickly give me answer. Nobody knows answer. What is equilibrium? Okay, equilibrium is nothing but when the load is, yes, balance position, or we can say the load is at stationary. When the load is at stationary or when the load is at rest. Okay. Now the load is at equilibrium position. Okay. So you can see, everybody can hear me, no? You all can hear me? Okay.
Yes, ma'am.
So here why I have taken this example, children, this is also a movable pulley. You can see this is one is fixed pulley and here this is movable pulley. So you can see here tension is supporting this. So you can see why the load is 2T and why effort is only T. So you can see this, whatever load is at equilibrium at rest position, the support is from this both the segment of the string. This is only one string, but support is given by both the side. So for this load, it is tension is twice. Tension is nothing but force. Okay. So now here you can see the effort is downward direction and the tension is applicable only for one string. We know that tension is always opposite to the surface of the load. So if the effort is downward, the tension should be upward. So for the effort, tension is only E. So to understand this, I have taken this example. Okay. Now to study about the mechanical advantage, velocity ratio and the efficiency, we should know three things. That is what all negligible when we are using movable pulley, single movable pulley. So what all things we have to neglect to get this three concepts, that is MA, VA and eta. Okay. So what we have to neglect? We have to neglect the mass of the string, mass of the pulley. Okay. If we neglect this, then only we can get it mechanical advantage or VA or eta. Friction between the string and surface of rim of the pulley. The third one is the friction at the axle or in the pulley bearings in the balanced position of the load. Same way, even for the single fixed pulley, these things are negligible for ideal machine, not for the practical machine. Again, I am informing you all here. Okay, and same way for the movable pulley as well. These three things we have to neglect. Okay, so let us find out one by one. That is, first we'll find out what is mechanical advantage for single movable pulley. So we know that mechanical advantage formula, that is load divided by effort. Load divided by effort is the formula for mechanical advantage. So already we got load is nothing but 2 times tension, 2 times T, that is mg is equals to 2T and effort E is equals to T. Already we have got here with the help of movable pulley. Okay. So now just substitute this value in the given formula. Load is nothing but what? 2T and effort is nothing but what? T. So children, here what we can get? T and T get cancelled. So what is remaining here? Just 2 is remaining. So what will be the mechanical advantage for a single movable pulley? It is 2. That means you can see here it's greater than 2. Okay, mechanical advantage is 2. Okay. Now we'll study about velocity ratio. See now, for the velocity ratio, we know the formula, that is the displacement of effort divided by displacement of load. This is the formula, correct? We have studied in the single fixed pulley also. So now, when you see this diagram, you can see here the pulley and the load is movable along with the rope and it is fixed, the rod is fixed at one point. So what is happening when we are applying effort on the string, one string, this load is moving upward direction, correct? The displacement of the load is from this point, you can see here, the displacement of the load may be after pulling up. If the load is here, if you pull up, the load will reach still here. So that means the distance covered is this much d. Okay, distance covered. But now when you are applying effort, children, what is happening? When you are applying effort, you can see this time, this side one rope and one rope only, but twice it is covered, distance covered twice, correct? That means here is 1d and here one more d. That means how many times d? 2d. Because when you are pulling this up, this rope, the distance is covered twice of this rope. So displacement of effort is 2d. But the displacement of load is only d, because load is only moving once up. So clear about this? Any doubt? So just substitute the value. The displacement of effort is what? 2d. So you have substituted, and displacement of load is just d. So d and d get cancelled. So what will be the answer again? Velocity ratio for a single movable pulley is again 2. Clear? So same answer we got. Like what is MA? MA is also 2. So clear about it? Any doubt here? Any doubt? How to find mechanical advantage for a single movable pulley and for velocity ratio for single movable pulley? Any doubt here, children? Any doubt?
No, ma'am.
Understood? Okay. Now can you tell me what is the formula for efficiency? What is the formula for efficiency? What is the formula for efficiency? MA is equals to VR. Wrong, Janet. MA is not equals to VR. Yes. Yes, 2 answers I got correct.
Ma'am, I'm asking a doubt now.
From Khushi and Vijay.
Ma'am,
Yeah, Vijay and Khushi is correct. Rest all students, what you all are doing? What is the answer? Many of them are attending, no? What is efficiency formula? Roshan. Yes, Roshan, correct. It is MA by VR. That is mechanical advantage divided by velocity ratio. So this is the formula for efficiency, eta. That is mechanical advantage divided by velocity ratio. Okay. So let us find out the answer for efficiency also. So for an ideal machine or ideal situation, we got mechanical advantage 2 and velocity ratio 2 in previous slides. So just substitute these values in this efficiency formula. So efficiency is equals to 2 divided by 2, 2 and 2 get cancelled. What will be the answer? The answer is 1. So for efficiency we got what? 1. So these are the 3 things for the single movable pulley. Okay, for only ideal situation. But when it comes to the practical situation, okay, it is always less. Okay, it is not equal to 1 or it is not equal to 100%. It is always less than 2. Mechanical advantage is always less than 2, but velocity ratio doesn't change. Why? Because it is a movement. Okay, it is a movement, so that the velocity ratio doesn't change. But mechanical advantage for practical situation is less than 2. But for ideal machine is not less than 2. Okay, and efficiency formula, if we see for the practical situation, if you substitute the value, again you will get answer is less than 1 for practical situation. And if you multiply into 100%, again you will get the efficiency is less than 100%. So children, you should know about the difference between for the ideal machine and for the practical situation. For ideal machine, it is always equal to 1 or equal to 100%, or it is for only for ideal machine, because we are neglecting the friction. But for practical machine, we are including the friction and the other factors. So it is less than 1 or less than 100. So this is all about single movable pulley. So you can see here also how the single movable pulley is useful for a child to move from one place to another place. So this is all about what? Single movable pulley. So next let us see about the block and tackle system. Okay. So about what is block and what is tackle already I have told you all in the previous class. So can you tell me what is block, children? What do you mean by block? Can somebody mute yourself and can you tell me what is a block? What is block? One minute, huh? You all are you're talking to me. I'm not able to hear you. Just.
And many pulleys are used in one place.
Yeah, can you speak now? Let me check.
Ma'am,
Yeah, now I can able to hear you all. Yes. So what is a block and tackle system? What is block? Many pulley attached in a fixed frame. You're not saying a frame. When a pulleys are attached in a frame, okay, more than the combination of two and more than two pulleys when attached in a fixed frame is called as what? Block. And what is tackle, children? What is tackle? What is tackle? What do you mean by tackle?
string or rope.
Only string or rope? What string or rope? What string and rope? String and rope is there, okay, string or rope is there. But tackle is only, if they'll ask what is a tackle, you will give answer string or a rope. You're going to give answer like that way. How you will give answer? No. When string or rope are bound in a pulley together is called as what? Tackle. You should not give the answer only string or rope. Okay. When the string or a rope are bound in a pulleys all together, it is called as what? Tackle. And when I'll ask a block, don't give the answer. Two or more pulleys. No. When two or more pulleys framed in a, it is framed in a given you can able to hear me? Okay. Why it is here echoing here? Okay, fine, fine. So clear about block and tackle now? Okay, so let us study in detail. See now here, we have taken here even pulleys, children. If you see here, I have taken here 4 pulleys. You can see 1, 2, 3 and 4. And you can observe that these 2 pulleys are fixed pulleys. Okay. And these 2 pulleys are movable pulleys. Yes. So you can see the combination here. 2 are fixed and 2 are movable. So we have taken even pulleys. If the pulleys are odd, how the adjustment will be? How we have to add that pulley? It is we have to add down or we have to add up? Up. Up when the force is given in downward direction. Keep it in mind. When we are giving force or effort, we are applying effort downward direction, that time you can add 3 pulleys up. But if we are applying the effort upward direction, then again it changes. 3 will come down and up will be 2. Okay, so clear about this? So let us first solve about the 4 pulleys. So we have taken here 4 pulleys, 2 are fixed and 2 are movable. And you can see how the string is bound in a pulleys and the load is attached here. So you can see, children, how many strings are there. That many tension also you can find out here. You can see this string, here 1 tension is mentioned. Okay, this string here T is mentioned, T, T and for T here it is mentioned. So that tension is only one segment of the string supports the effort E. Okay, only for effort only one tension is there. The meaning of this is for effort only one T is there because the effort is applied on only one segment of a tension on a rope. So E is equals to what? T. Always E is equals to T. Okay. Now let us see how many times T is there for load. Load is supporting for how many strings? See now, for load is supported for this one string. So from this string also the load is supported, from this string also is load is supported, and from this string also load is supported. When you can, how you can find out? You can just draw a single line like this way. You can see here. See here, this load is supporting with this all 4, not by this. So 1, 2, 3, 4. So load is equals to how many time tension? It's 4 time tension. Correct? It's 4 time tension. So what we have taken, load is equals to 4T and effort E is equals to T. Okay, so now these values we have to substitute in a mechanical advantage because we have to find out mechanical advantage, velocity ratio and efficiency for block and tackle as well. So we know the formula load by effort. So substitute the value, that is load means 4T and effort is T. So T and T get cancelled. What will be the answer? 4. So mechanical advantage is equals to 4. And if you observe, children, you can find out that so number of pulleys in a frame are also 4. See here, mechanical advantage we got answer 4. And as well as we have here 4 pulleys. So any doubt in mechanical advantage for block and tackle? Have you understood how we got 4 answer? Any doubt or shall I move further? Okay. Everybody clear? Or only Vijay is saying no doubt? All of you have understood? So in the next, this you can see mechanical advantage is equals to 4 is equals to total number of pulleys in the system. So as I have mentioned you all, here there are 4 pulleys and the mechanical advantage is also 4. So we have written this statement. Total number of pulleys in the system is equal to the mechanical advantage, that is 4. We got the same answer. Okay. So the next one, when the pulleys are in odd. When the number of pulleys, we have taken even number 4, we got this mechanical advantage. Now let us find out when the number of pulleys in odd number. Now like 1, 2, 3, 4, 5. 5 pulleys we have. So let us find out what will be the mechanical advantage when there are 5 pulleys. Okay. So now first we should know what is E is equals to how many times tension, and load L is equals to how many types of tension. So the tension in only one segment of the string supports the effort. Okay. So when it is supporting the effort here, so how many times for effort, how many times tension you can see here? Can you tell me? Effort is applied for how many ropes? How many rope segment? 1. Very good. So you can see here the effort is downward direction. This is the effort line. We are applying effort on this. Okay. So the tension is only 1 because it is only one segment. So E is equals to T. So now can you tell me a load L is equals to how many times T? Load L is equals to how many times T? Can you tell me? Load L is equals to 5. 5T, correct, very good. So now you can see here, if you draw like this way, so you can see here how many this pulleys are supported by the string 1, 2, 3, 4 and 5. Okay, so L is equals to what? 5T. Correct. So now for mechanical advantage, what formula we have to use, children, now? What is the formula for mechanical advantage? Yes, L by E, load divided by effort. So now substitute those values here. See now, mechanical advantage, MA is equals to load by effort. So L is equals to 5T. From a previous slide, we have got this 5T and effort E is equals to T. So mechanical advantage, MA is equals to 5T by T. So now here, you can see that here T and T get cancelled. So what is the remaining here? Answer is 5. Correct? So 5 is the answer. So mechanical advantage is 5. So if you observe here again, children, you can see that our number of pulleys also are 5. See, 1, 2, 3, 4 and 5. And if you see, the answer also is 5. Correct? Understood? Yes or no? Okay. Now let me explain you about, now if you see here, we are applying effort downward direction for this 5 pulleys. That time we got mechanical advantage 5. Even velocity ratio will get same, no? Or some different answer will get velocity ratio. What will get? What will get velocity ratio? Yes, velocity ratio is equals to what we'll get? What is the velocity ratio formula? What is the velocity ratio formula? Displacement of effort divided by what? Divided by displacement of load. So if you, what is the displacement of effort according to this? How many times effort is there for velocity ratio? How many times the strings are moving up? It's moving 5 times only, no? So x, how many times we have to take here? Again 5 times only we have to take x also. Correct? Because strings are moving 5 times, so here again you have to write it's 5 T divided by displacement of load is how many times here? The moment of the load is how many times, children?
5.
Moment of a load is 5 times. The moment of the load is how many times? How many times the load is going up?
1, 2.
This load, how many times it is going up, children? If I am pulling the strings, it's going how many times? It's going only one time, no, up. Yes or no? If this load, I will give the efforts downward direction, load will move upward direction only one time. Only this distance it covers. But when the effort is applied, the strings are moving 1, 2, 3, 4, 5 times strings are moving. Don't get confused. Okay. The effort, displacement of effort is 5 times. I'm not talking about tension here for velocity. Don't get confused. For velocity, I'm talking about the movement. Okay. And the displacement is only one time. Clear? Any doubt? So here, divided by again T. So what will be the answer? It's again 5. Yes. And if we find efficiency, what is the formula of efficiency again here? What is the formula of efficiency? MV divided by VR. So what will be the answer? What is MV we got? What MV we got? What is mechanical, mechanical advantage, ME? What is ME we got? 5. Correct. 5. Divided by, what is VR? VR also is 5. So what will be the answer? Answer is 1. So efficiency what we got here? 1 when there are 5 pulleys in a frame. Correct? So velocity ratio we got 5 and efficiency we got 1. Okay, this is when the 5 pulleys we have taken and when we are applying the efforts in a downward direction. So clear, children, about this? Any doubt here? Any doubt? If I will take number of pulleys 5 only. Pulleys I am taking 5. Okay. But effort applied in upward direction. So what will happen when effort is applied on upward direction? What do you feel? Whether the answer is same, MA is equals to 5 only will get. What do you feel? See, let us draw now for that. I don't know whether I can draw it. Okay, let me try. Okay, let me draw. First, I'm taking 5, no? So, this is the frame I'm drawing. Just a minute. Okay, I will draw it from up on. Okay, just see effort applied in upward direction. For that, we have to draw now. For example, you have to draw very straight, children, okay, with the help of scale and all. So, how many pulleys? See, one. This is bigger, so little bit the radius should be again smaller than this here when we are drawing it. So little smaller than first, and then again little smaller than second. Okay, these are three pulleys we have taken, and then here we have to draw one hook. Correct. So now again down we have to draw again a frame. So here, just a minute. So now when we are drawing here, because it is now small will come and then big when it comes to the upward direction. Okay. Now for example, my effort is upward direction. That means string should come like this way. Correct, children? Correct or no? Yes or no?
Yes, ma'am.
Yeah. So now draw the string. So the string will come like this way from here. Okay, from here I have to draw. So it will come straight line like this way up from this. Then it will come down to this string. Then it will come up. Drawing went wrong. I'm not able to draw here. So from here, just a minute, children. I will draw on the notebook and I'll show you. But wait, 1 minute. Okay, can you see me here? See, I will draw and I'll show you. Okay, in the notebook. Huh? So, here we have to we have to draw 4 strings. You can see, no? You can see here? Okay, on the blackboard only I'll show you all. You can see, no? You can see the blackboard, children? See now here, if I am drawing this frame, okay, first pulley will be bigger, okay, then the second little smaller, and then again it is very small. So these are the 3 pulleys up we have drawn. Then here hook will come like this way. Okay, now again down. This is the frame. And we have taken the example of 5 pulleys. So first, when the effort is applied downward, first will be smaller and the next will be bigger. Okay, correct? Yes. So now effort I am applying downwards means string should come like this way. Effort I am applying upward. The string should come like this way. So the string will go from here. Then straight line should be. Okay, it moves up. Then here it comes down like this way. Okay. So now here From this, it winds up. Again, it goes up. It should not touch. The two strings should not touch. It winds up. It comes like this way. I'm correct or gone something wrong? And it is attached to this way. Okay. So you have to draw like this way first fully. Okay. Now the effort is applied one direction. So how many strings are there? See somewhere 1, 2, 3, 4. I am missing somewhere here. Something is gone wrong.